Hey there, welcome to Gallo's AP STEM. Today we're covering topic 3.5 of the AP Calculus curriculum, so if your mind's ready to function, let's dive into selecting procedures for calculating derivatives. This topic is about knowing when and how to use the derivative rules. It's like having a toolbox full of wrenches, you just gotta know how to use them. We have learned a bunch of rules so far, like the power rule, the product rule, the quotient rule, and most recently the chain rule. But how do you decide which of these to use when you see a complex function? That is exactly what we're going to master today. Let's start with a recap of the main players. May I reintroduce to you the power rule, used for simple polynomials like x to a certain power. You take the exponent and you multiply it by the base, and whatever is in the exponent you subtract it by 1. So the derivative of x cubed, for example, would be 3x squared.
Now onto the product rule.
You use this when you have two functions multiplied together, like g of x times h of x, for example. Remember, to properly use the product rule, you must multiply the derivative of one function times the normal version of the other one, and vice versa. After this, you just add them together, and boom, you've got a derivative. The quotient rule, if you can remember, is where you have a function divided by another function. This is just like the product rule, except you subtract both products and you divide it by the denominator squared. Now, onto the chain rule. This is where a lot of people can mess up because this is the most complicated one. It doesn't involve multiplication or division, but rather an inside function and an outside function. What a lot of people miss about the chain rule is they find the derivative of the outside and they keep the inside the same, but they just forget to multiply by the derivative of the inside as well. The absolute key to selecting the correct procedure is by analyzing the structure of the function by asking yourself these 5 questions. 1. Is it a simple polynomial or constant? Power rule. 2. Are there two functions multiplied together? Product rule. 3. Is one function divided by another? Quotient rule. 4. Is there a function inside of another function? Chain rule. And 5. Is it a combination of these? Then you'll need to use a combination of rules. So just for funsies, let's look at a combined function for once. Here's an exciting one, ln of x squared times cosine of e to the 3x power. Amazing, I know. So without further ado, let's break down how we would even approach to finding the derivative of this beast. Recall the derivative of ln of anything. It's 1 over the inside function times the derivative of the inside function. Remind you of anything? Exactly, it's the chain rule. Here our inside function is x squared times cosine of e to the 3x power. So our first step would to put this all under a numerator of 1 and multiply it by its derivative. But here's the thing, our inside function itself is going to require more than one procedure to find the derivative. Can you guess what we use first? That's right, we use the product rule because it's two things multiplied together. Getting started, we would multiply x squared times the derivative of cosine of e to the 3x power. But here's where things get interesting because we have to use the chain rule. This would turn out to be negative sine of e to the 3x power times e to the 3x power times 3. 3 being the chain of e to the 3x power, and e to the 3x power being the chain of negative sine of e to the 3x power. Very complicated. Now we're not done with the product rule yet because we still have to multiply the derivative of x squared by cosine of e to the 3x power. And using the power rule, x squared would go to 2x. If only all the steps were this easy. Simplifying, our results from the power rule should yield 2x times cosine of e to the 3x power plus x squared times negative 3 to the 3x power times sine times e to the 3x power. Now we multiply this huge expression, putting it in the numerator of the fraction where we got in the first step, and boom, we have our final answer. So to take away from all this, to determine which order of procedures you need to use to find the derivative of complex functions like these, you have to work from the outside in, finding what wraps the entire function. And what I mean by something that wraps around the entire function is something that applies to every single variable. For example, when you're using a chain rule on something like cosine of 2x, the cosine, the trig function, is a thing that is applying to everything inside, the 2x. But this isn't just limited to the chain rule. In fact, you could have two composite functions stacked on top of each other, therefore you must use the quotient rule first. Now if you want to know about calculating high order derivatives, then go ahead and subscribe and check out the next video. I'll see you in the next one.